Hello everyone, my name is Anvita Bansal and we are back with another lecture from SDE Sheet. So let's see our problem for today. Let me move you to the question and simultaneously let me check if you guys are able to see my screen. First let me check if you guys can see me. Fine. So let's move to our problem for today. Today we are going to discuss sorting elements of an array by frequency. So let's have a look. So your problem is that you are given an array of integers. Sort the array according to frequency of elements. That is, elements that have higher frequency, they come first, and the others with the smaller frequency, they come later on. And if the frequencies of two elements are same, then smaller number comes first. These are the two things that you need to understand. Okay, finally. Looking at one of the test cases here, let's have a look. So basically, if you see at the problem here, you can see that they have not written the function. We will be writing the function for ourselves, and also we are going to give the input from our end, right? So this is one thing that we have to do in this problem, extra from what we have been solving so far. Okay, not something to be bothered with. Now the problem is understanding this problem. Let's say this is your test case. In this test case, what is the length of this array? This array is of length 5, and how many values are there? There are total 5 values, but you can see some repeating elements here. So if you check, 5 comes 2 times, 4 also comes 2 times, and 6 comes 1 time. So in the output, you want an array in such an order that the element which is repeating maximum number of times should come first. And here you see that there are two elements that are repeating 2 times, 5 and 4. So which element should you consider coming first in your output array? So for that they have told you the smaller element should come first. Okay. So 4 followed by 5, and the least frequency is of element 6, which occurs only one time, right? I hope you have understood the problem statement. And if you guys have joined the session, you can just acknowledge on the chat. Let's move ahead. Okay. So coming onto the whiteboard, let's understand taking one example here. Let me take some example. So let's take it 2, 2, 5, 6, 1, 2, 1, 5. Right? Let's say this is your test case. Now this is your ARR you are given. What should be the output? The output should look like, first of all, let's understand what are the frequencies here. Corresponding to 2. How many times is it occurring? Let's first write the distinct elements here. 2 is one such element, 5 is one such element, 6 is one such element, 1 is one such element, and rest of them are the repetitions of what we have written. So let's write their occurrence. 2 is coming 1, 2, 3 times. Okay, these are the frequencies. 5 is coming 1, 2 times. Okay. 6 is coming 1 time. 1 is coming 2 times. Have we left any element? Let's check the total number of elements. We can verify 3, 2, 5 and 2, 7 and 8. 1, 2, 3, 4, 5, 6, 7, 8. So total 8 elements are there. That means we have covered all the elements and their occurrences. So looking at, this is the frequency and this is the element. So looking at, let me check if you guys are able to see my screen. 1 second. I hope you are. Cool. Fine. So looking at the frequencies, which element should come in your output array in the first place? That should be the element with highest frequency, that is 2. And you should also repeat them as number of times they are occurring. So it's 2, 3 times. So I will write 2, 3 times. Then followed by, there are two numbers with same frequency, and that is 2. So which element should come first in your array? The one with the smaller value, that is 1. So 1 followed by 5, it is also coming 2 times, and the last element is 6. So this is what your output array should look like. Now, first thing in this problem, you need the higher frequency element first. Okay, first and then followed by other frequencies in that decreasing order. Basically it's in the decreasing order of frequency, right? Now in order to know what is the frequency of elements, you can do one thing. Either you can take a 2D type of array. What this array would look like is, it will traverse over your entire array. Then for each array you will count the number of times it is occurring. For 2 it is how many times? Till now it is 1. Then again you are encountering 2. So you will increase this index by 1 again. It will become 2. Then you are checking for 5, it is only once. 6, it is once. 1 you are encountering once. Then you are checking for 2, and for 2 it is you have to keep a track that you have already found 2, so you are increasing the count of 2 in that case, and so on and so forth. So from this can you get some idea of what kind of a data structure can you use to store element and their frequency? So the kind of data structure we can use in this case is hash map. Hash map will help us better to store the frequencies of elements and track that which element has what frequency at what stage, right? If we simply create a 2D array, then you will have to keep track of if this element already has been found in your array. So we can easily use hash map for this purpose. Okay. Now when we use hash map, next step is, how do we keep track of that sorting should be in order of decreasing frequencies. We have to track this. Okay. Now coming on to, it's very easy problem. If you this explanation is going to be very easy. Now already you have done this thing, that is you have, for let me just write some pseudo code for you. Let's say what you are doing, for I0 till n minus 1th index, right? You're traversing over your array, and in your map you are inserting the values. If they are not found, map dot put arr of whatever. If it's an array list, then arr dot get I, otherwise arr of I. And if it is not found, then you will put 1. If it is found, if let's say this, I'm not going to write exactly, this is for your understanding. Okay, if map dot contains key, for that the prior thing I expect is that you have understanding of maps and what all functions we can use within maps, right? So if map dot contains key, what is that key? ARR of I. That means if that value is already present in your map, you will put against that value, you will increase the frequency of, see, this is key value pairs. This is key value pairs. A map is a key value pair, where your key is going to be your ARR of I at any instant, and value is going to be the frequency of that array. That is the number of times it is occurring, right? How many times, number of occurrence. Okay, so if I look at this element 2 in my map right now, there is nothing. Let's say there is nothing right now in my map. So what it will do, map dot put ARR of I and 1, right? Sorry, if there is nothing, then it will put 1. But if let's say now I have put 1 already, again I am encountering 2, so it will go with this condition. It contains already, so map dot put ARR of I, whatever value is present in the key, then add 1 to it. So map dot get whatever value is at ARR I plus 1. That is what you should store with. Otherwise, in else case, you are checking it for the first time, you are encountering it for the first time, map dot put ARR of I 1. Okay, so finally your hash map will look something like this. Hash maps situation would be like this. 2 is the key, so its value would be 3, right? If 5 is the key, 5's value would be 2. If 6 is the key, 6 value is 1, right? If 1 is the key, 1 is occurring 2 times, 1's value will be 2. 5 we have already seen, so there are 4 distinct elements, 2, 5, 6, 1, 2, 5, 6, 1. So this is how your map should look like by the end of iteration over this array. Fine. Now what you have to do, other task will be, you are out of this loop. Now you are going to check what are you going to check? You are basically going to sort. Let's say arrays, either if you are taking array, you will use arrays dot sort. If you are using an array list, then you will use collections dot sort, right? So in our problem, we will go ahead with list. So let me write arrays here, because above we have written ARR, array. So arrays dot sort, or let me go ahead with collections only so that you can understand how we are going to write it in code. Okay, I'm just writing pseudocode here for you. So collections dot sort will do what? If it was a simple collections dot sort and I am passing a list here, which is ARR, let's say, then what will happen? Your array will get sorted, right? Any array, if what collections dot sort does is, you have a list, an array list, whatever is there, 4 3 4 1, it will sort your array and it will look something like this. But you know, first of all, what do you want to sort? First of all, what do you want to sort? You want to sort what are the frequencies of these elements. Then if I sort them in a descending order, just sort them in descending order, the frequencies. Let me write the frequencies in descending order here. Understand, 3 followed by 2 followed by another 2 followed by 1. Now corresponding to 3, in my output array, what is there? 2. So in my output array, I should return 2 3 times. Then frequency 2 comes in my sorting in descending order. So against 2, I have two numbers, 5 and 6, 5 and 1. The one which is smaller should come before, and then the other one is 5, it should come after, and the one with the least frequency is here. So my idea is, so the logic behind is, sort the free map, basically sort the, in your hash map, sorted by frequency in descending order. Sort frequencies in descending order. You understanding this? Now if I sort the frequencies in descending order, I will have map in this way, something like this. Not map exactly, I will have frequencies in descending order, and I should have the values finally in this order. So as number of times they are occurring, 3 times 2 followed by 2 times 1 followed by 2 times 5. And there is a catch here. If frequencies are same, then sort in ascending order. Sort what? Not frequency, sort the key in ascending order. Sort the values, or what do you say, sort keys in ascending order. Okay, so can you think of comparator here? Use of comparator, that is what they best do. I can implement comparator, or in my collections dot sort, I can do something like this, collections dot sort. Okay, what am I going to do? First of all, I will pass the list, array list, which I want to sort, right? And after that, I will pass that I want to implement comparator, right? So integer comparator, I will write it in the code properly, comparator of type integer, right? And this should implement your comparator interface, for which you are going to write the compare function, right? Your compare function you are going to write. How will you write the compare function? That is only the catch. It will handle everything. So basically, this is your new comparator. Now compare function will have two values. What are those values? These are going to be two values that are going to be compared, integer a, let's say integer b. Okay, and what are a and b? A and b are the values of your array list. In your list, whatever the values are, 2, 2, 1, 4. So let's say a is 2 and b is 1. So these are going to be the value in your arrays. Now I'm comparing, and I know I already have a map. Which will have key and their frequencies. So 2 is coming 2 times, 1 is coming 1 time, and 4 is coming 1 time. Just have a look at this array, okay, for current understanding of how I'm going to implement this compare function. Okay, so this was something like this. Just you have to very keenly understand this part. If you didn't understand, then maybe you'll not be able to solve this problem on your own, even though you have understood the logic. So the entire catch is for you to understand this step of your solution. Okay, so you have two integers which are the elements of your original array. Fine, that I'm passing. So what does a compare function do? Compare function internally must have some lambda function, right, which compares a and b. In this depth I'm not going to go right now, but I assume you should have understanding of comparator. If not, you should go to previous videos and understand this. Okay, so it will compare a and b, and depending upon which value, if it is greater, a is greater than b, it is going to return a minus b, right? So in normal cases, if a is greater than b, it returns 1, otherwise it returns -1, and if they are same, then 0. So in case it is greater, it will swap it so that the smaller value comes before. And if I pass b minus a, let's say, and in that case what will happen, it will sort in descending order, right? I'll tell you what. Now first understand this. So we know that we have also created a hash map which is looking like this. So a is 2, let's say a is 2 and b is 1. I have passed these values. Let's see what are the frequencies of these values. Okay, so let's say I am storing frequency 1 in freq1, that is map dot get a, and frequency 2 is map dot get b, right? So this will give you frequency. Now you know when you want to sort your array, the one with higher frequency should come first in your array. So I can say descending order of frequency is what I want to apply my compare function on. So if both the frequencies are not same, frequency 1 is not equal to frequency 2. So in your comparator function, if you are writing a compare function, if you are customizing it yourself and you want to sort on the basis of values, whatever values are there on which you want to compare, and you want it to be in descending order, what do? You just reverse the values, the order of the values that are being passed. So in this case, if we want it to be sorted in the descending order of frequencies, I am going to return frequency 2 minus frequency 1. If let's say frequency 1 is my value corresponding to first input and this is corresponding to second input, so if I reverse the order of these values, so now the output of this compare function would be that if frequencies are not same, frequency of 2 was 2, frequency of 1 was 1. What I did, I compared 1 with 2. 1 is less than 2. So ideally, if it is less than 2, in ideal case, what should have happened? It should have sorted on the basis of this comparison. But we are not passing frequency 1 minus frequency 2. We are returning opposite. So what lambda function will assume is that since this value is negative, that means my 2 should come before 1, because originally lambda function is supposed to return a minus b. Basically it operates like a minus b, but we are passing b minus a, so it is going to do its own task. It will compare if the value is less, if this value is less than this value, it will return -1. But since we have reversed the order of the inputs that we are passing, this will swap in this way that the one with the higher frequency will come in the beginning of your array, right? And if the frequencies are same, you want to sort in the ascending order of the original values. What were the original values? A and B. So if let's say frequencies are same, which in case, let's say your input is 1, in case of same frequencies, when your input is, let's say I am passing A as 1, this is your 1, and B as 4, right? So 1 and 4, what are the frequency? Frequency 1 will be 1 and frequency 2 will also be equal to 1, because both are occurring one time. So in case of same frequency, in your sorted array, I want the value with smaller, the element with smaller value to come first. So in that case I will do my comparison on else. If they are not equal, you are returning in this way. Otherwise you want to return a minus b. That is the simple order of two elements. If a is smaller than b, then no swap will happen. If a is greater than b, swapping will happen and a will go behind b. It will come like this. So a is 1, b is 4. 1 minus 4, that is minus 1. That means no swapping. 1 will come before 4. That is what we want to do. Fine. So I hope you have understood this problem, and we are doing this for all the elements in your array. So finally your sorted array would be the desired array. Okay, any doubt so far? Let me come back to your any doubt so far, you can ask me in the chats. Otherwise now let's move to the code and start coding it. So the very first step, as I told you, is that we are going to take the input asses. They are taking the test case first, then according to number of test cases we are giving input. In input, what do we have to give? Length of your array n and the entire array. That input you have to take from the user. So int n, first let's give the scanner as, just a second. Fine. Int t to s dot next int test for test case. Now for all test cases you have to run a loop so that you can give the output for all the test cases, right? For each test case you have to give two inputs. One is int n, that is the length of your array, right? And the other is the array itself, int arr. So you will see I am writing integer arr new integer, not int and integer, because in the further step where I will be writing the comparator where I am writing the compare function, so the comparator takes the wrapper itself. The wrapper, it's a wrapper function, so it takes the input in the form of integer. So it's better that I define my array also of type integer. You will understand this when I go ahead in this code. Okay, so let's take the input for this array j, because I have already used I above. arr of j is equals to s dot next int. Fine, is that okay? Okay, then you come out of the, not out of the loop, then you are out of this loop where you are done taking the input, and then you want to write another function where you will be doing your task. So public static int, let's say sort, we are sorting it, right? So let it be void, we will print the solution there only. And let's do one thing, it is taking list of integer, because we are going to use collections dot sorts, so it is compatible with array lists, so we are using that integer. It will be of type integer arr, and arr will work, but for avoiding confusion I'm writing this int n. So that is what our function is going to look like. And since we are passing array list, let's take a list here. Let's declare a new list of type integer. List is new is arrays dot as list. We are converting our, we took array input array of the form array, right? We took the input of form array. Now we are converting it into list of integer type, right? That is why I've written this statement here. And then you are passing it to your sort function. So in your sort you pass list and n. Fine. So this is the task of your main function, calling of sort function. What does sort do? First thing, let's create the hash map. Hash map of type integer, map is new hash. Fine. Then you have to fill the values in your hash map, basically key value pair, which will be the element and the corresponding frequency. So I goes from 0 to n. If map dot contains key what? List dot get I, that is the value at which you are iterating in your array list. If it contains already list dot get I, then map dot put at that position list dot get I, at that position you put list dot get I plus 1. Fine. So at this key you are giving whatever the value was, list dot get I, map dot get list dot get I, map dot get list dot get I plus 1. I hope you have understood this. So in your map, if the value is already present, that element is already present, so at that element you want to increase the frequency by 1. So map dot get list dot get I, that is the frequency you will get, and you are adding 1 to it. Otherwise, for the first time you are seeing that value, you will simply put it in your map as list dot get I comma 1. Fine. Now just come out of this loop. You are done with the filling of your array. Now you want to sort it. So collections dot sort is what you are going to use. You are going to pass the list that you want to sort. Then comparator, new comparator is what you are going to define here, the interface comparator of type integer, right? It will take 2 inputs of type integer that we will declare in the compare function, public int compare. What is compare taking? Compare will take 2 values over which we will compare and decide. That will be of type integer a. Why? Because comparator wrapper class is itself taking the input of type integer a comma integer b. Okay, now a and b are actually the elements of your array. They are the elements of your array, and in the map, as per these elements, you have stored the frequency corresponding to these elements. So you want to know the frequency, because on the basis of frequency you want to sort, right? So let's say int frequency 1, int frequency is equal to, is what? Map dot get a, and let it be integer. Frequency 2 is what? Map dot get b. Okay, now if the frequencies are not equal, if they are equal, then you are going to sort on the basis of values a and b, otherwise on the basis of frequency 2 and frequency 1. So if frequency 1 is not equal to frequency 2, return opposite, because you want descending order of sorting, minus frequency 1. Else if they are same, return a minus b, because in this case you want to sort on the basis of the elements in the normal ascending order. Okay, this is what you are doing in collections dot sort. That's how you write it. Okay, there are other various ways also. You could have implemented your comparator function using implements, right? And you can also use dot compare to. This is one way that I have chosen. You can choose in any other way if you want to. Okay, fine. When you come out of this, your array would be in sorted order. So let's do one thing. Let's print it here. 0 I is less than n I plus plus. System dot out dot print list dot get I, and I'm giving spaces here. And since we are we are till here we will be done with printing the output in this way, if syntax and everything is correct, the logic we discussed in this code. And then you will be returned back to this position after you are done with the printing. Then again this loop will be called for another test case, and then you will be calling this function. Then again this array in the sorted order will be printed. But if I keep this code in this way, then this another sorted array will be printed right next to this array with just one space between the last element and the first element of other array. So I need to give a new line, which I will give here, out print, so that for every new test case a new line is printed, and then we are printing our new array in the sorted order. Okay, system.out.println. Let's check if okay, so it ran in the first case. I directly submitted because it takes time to compile, as it's a little lengthy code in terms of complexity. Also, let's compile and run for you because it passed in one go, which I also didn't expect, but okay. So you see your output, your expected output and your output match. That is why this function, this entire code is done. Let it pass. You saw it, it has already passed, but maybe let's wait for it. Fine, I hope you got it. So we have used sorting, our inbuilt sort function method only, that is collection.sort, and typically even if you check, it will take n log n of your time complexity, right? Because you are doing operations on elements. Like first you are doing this operation, then it will be of on time, then n log n time, and then on time for printing. So on plus n log n plus on, so it is going to be predominantly n log n of time complexity. Fine, I hope this is clear to you. That was all about this problem for today. You can have a look at the code. Meanwhile, I'll check if you have. So since the series is going to be in Java, so all the problems that I take are going to be in Java only. And this is not recorded. I come live every day 7 to 8 p.m. So all you are going to learn here is going to be live. You can write your queries, your doubts in the chat. If at any point you did not understand the question, you can write it. And you can also repeat the video once you are done with the live session. If you want to revisit the video and understand any part which you have not understood during live, you can obviously come back. The videos will stay in this playlist, GFG Practice SDE Sheet. Okay, so that is all about today. See you all tomorrow in the next lecture. Thank you everyone. Bye bye.